This is 4.6a. We're going to go back a little bit and head towards what we're going to learn that's new today. So, when we do integration by substitution, let's say that we say u equals x squared plus 7. Then what we have done is we said, well, let's take the derivative, du dx, and that equals 2 to the x. Next, what we did is we multiplied both sides by dx, and we got du equals 2x dx. Okay, well, what we're going to do now is we're going to go immediately from this step to this step. We're going to skip that middle step because we now know what we're doing. So here, if we have u equals x squared plus 7, we can say du, we take the derivative, is 2x, and we attach our dx. Okay, so we're going to utilize that when we learn our new material. So let's do a couple examples of that. If we let u equal x to the fourth, then du, we take the derivative, 4x cubed, and we attach our dx. Okay, so that's one example. Let's do another example. If u equals x cubed plus 5x squared, then du, you take the derivative, is 3x squared plus 10x all times dx. Okay, very good. Now we're going to do an actual problem using integration by substitution. And I promise you this is going to go into what we're going to be learning. Okay, so here we're going to take an integral of the quantity x squared plus 7 to the 6th power times 2x dx. Okay, so we look at this and say, well, what would we like to be our u? Well, this would be a good candidate for a u. So let's see what happens. If u equals x squared plus 7, then du equals 2x dx. Now that worked out perfect because here's our 2x dx. Okay, so we can replace our du with that, and we're going to put our u in here, and we get u to the 6th. And now we can integrate because we have all u's. Okay, integrating this, we get u to the 7 over 7 plus c. Okay, now let's look at a new type of problem. Integrating x times e to the x dx. I'm going to put a question mark here. Can we integrate by substitution? Well, let's see. Let's try different u's and see if it works. Let u equal x, then du is just going to be dx, 1 times dx. Okay, does that equal x dx? No, it has the dx, but not dx. Okay, now we need to all be in du, so timesing it by x won't work. So let's go the other way. Let's say u equals e to the x. Then du equals e to the x dx. Now again, we have our dx, but now we've got this e to the x, and that's not what we needed. We needed an x. So neither of these are working. So we cannot use substitution. So we're going to use a new method.